Okay, we will start the session now. If the last to join. Okay, so we will start the session. Good afternoon, everyone. My name is Gajanan Kadam, and I'm the subject teacher of for the big data. And today's topic is Spark for data analytics, for big data analytics, fifth unit. And in this chapter, we will see about everything about the Spark. What is Spark? What are the key concepts? Then what is RDD? And what is the workflow? And what are the questions that we are going to having? Okay, so I will highly recommend you this course of Udemy Tamil with big data, Apache Spark, and Python, and totally it's hands-on session. And for this session or for this PPT, we will refer the book from the Das Gupta, Practical Big Data Analytics, for the pack publication. Okay. So I don't know whether you have previously worked with big data or not. So there is a good chance that if you are working with big data, then you have to work with Apache Spark. And in this session, we will discuss about what is Apache Spark firstly. Okay. So those of people who don't know about Apache Spark is an open source multi-language platform that enables us the execution of data engineering and data science tasks on a single node or machine or clusters. As we are most of the time we are performing the data task, data related tasks such as data science or data engineering, mostly on a single node machine, or we can perform it on the big data. For big data, we can perform it on the clusters, and most of the time we are processing the data on the Hadoop clusters. Okay, so that is exactly the Hadoop. We are processing the data of the clusters, and we are talking about the Spark here. So Spark is very much compatible with popular programming languages such as we can say SQL, we can say Scala, Java, Python, and R, making it one of the most preferred choice for the data analytics and data scientists. Okay, so in this series, we will see a little bit about what is Apache Spark and what are the contents of Apache Spark. Then what are the concept of RDD, data frame, data sets, DAG, and officially the workflow. So we can say that little bit we are talking about the history of Apache Spark or the advent of Apache Spark. Before the arrival of the Apache Spark, Hadoop MapReduce, as we have saw it in the previous chapter, before the arrival of the Apache Spark, Hadoop MapReduce was the most popular option for handling the big data set using parallel and distributed algorithms. So MapReduce has a multi-steps such as a sequential processing for execution. In each step, MapReduce retrieves the data from the cluster, perform the operations, and write the data back to the Hadoop distributed file system, that is HDFS. Okay. So since every step is a necessity for the disk to read the data and write it to the back, and the data execution of MapReduce job is hindered by inheritance latency. Latency means we are getting the output very slowly from the input output devices. So that was the problem in the Hadoop. To overcome this issue, Apache Sparks emerged as a research project in UC, as we can say, Berkeley in 2009. So this journey led to the Spark publication, that is Spark cluster computing with working sets. It was an open source in June 2010, I guess. Okay. So subsequently, we can say that from June 13, 2013, Spark entered the incubation step with the Apache Spark Foundation, and later it is earned as a status as Apache top level projects February in 2014. So from 2014, we are using this Apache Spark for handling the large type of data. And again, talking about the why it is so much popular, what are the key advantages of it, and why it is so efficient with the big data. So it is achieved by this conducting processing memory. So thereby reducing the number of steps in the job and promoting the data reuse across various platform operations. I will repeat the same. So we can achieve most of the efficiency in big data by we are processing the memory, we are processing the data inside the memory, and thereby reducing the number of steps in the job and promoting data reuse across various parallel operation. So which Spark only one step is required where the data is read into the memory, operations are executed, and results are promoted return back. So this is the streamlined approach that we can say that it is 10 to 100 times faster execution than the Hadoop. So Spark's in-memory caching. You know what is cache memory? Cache is a small type of memory which resides to the processor. It is a very small type of memory which can access the data very quickly. So Spark's in-memory cache enhances the performance of machine learning algorithms, as well as it can repeatedly invoke the functions on the same database. So we can say rather than database, it is on the same data set. Okay, so it can perform with the machine learning algorithm well with repeatedly function on the same data set. So this data reuse is facilitated through the use of data frames. What are the data frames? An abstraction built on the top of the resilient distributed data set, that the topic which we are going to see later. So we will discuss RDD later. This innovation that makes the Spark significantly faster than MapReduce, and particularly in the machine learning activities, while preserving the scalability and fault tolerance. Okay, so what are the main features of Spark? Spark is most probably used for its scalability, and we can say that we saw the scalability feature earlier in the Hadoop as well, but moreover for the fault tolerance. So what is mean by fault tolerance? If you don't know what is the meaning of fault tolerance, if you are having, this is the distributed computing, right? If you are having server 1, server 2, server 3, and in those server, if one of the node goes down, then what is the possibility of having the availability of that particular system? So there is very little possibility. But what is fault tolerance? Fault tolerance means that the data available on one node is replicated on the other node as well. So if there is a possibility by physical damage or from the server engaging, that server is highly busy and we are not able to access or process the data, so we can use the replication of the server copy as well. So with this replication, we are having the fault tolerance. The data is maximally available. Okay, so availability of data is available, availability of processing with available with the help of the fault tolerance used in the Spark. So basically, Spark is 100 times, 10 to 100 times faster than Hadoop, because we do not need to only read the data, write the data to the memory. We are processing the data in the memory as well, and it is providing for basic APIs for we can say that different type of popular languages such as Python, Java, Scala, SQL, etc. And it is having the versatility that we can stream, batch process the data, stream process the data along with machine learning, which makes the Apache Spark very much efficient for the big data. Okay, so this is basically the advent of Apache Spark. This question is asked for the university exam. So, what are the limitations of Hadoop? As we talk about Hadoop, so Hadoop relies on the data storage, that is reading the data, writing the data, and leading to high I/O overhead. As we know that input-output devices are not that much faster as for the processing purpose. So, the input-output are quite having the speed time low, so that we are increasing the overhead on the I/O devices with the help of Hadoop. Means we are totally relying on the disk storage, and processing the large data set across the multiple servers incurs to performance bottleneck. What is meant by bottleneck? If you are having the load increase here, then the performance is automatically reduced. So we can say that there is performance bottleneck. If there are multiple servers, larger database across multiple servers, then we are having the performance bottleneck. Okay. So third point discuss that the machine learning task requires iterative computations are inefficient due to repeated reading, writing with the help of we can say via IO devices. So we can see the most important point is repetitive, iterative computations means repetitive task. So it is very much efficient for the repetitive task. And if you are talking about the IO bound, these are the IO bound. So see this. This is asked in the university exam as well. So what are the limitations of Hadoop? and how Spark is overcoming the limitations of Hadoop. Okay, so this was the first section, that IO bound operations. In the second, we can say that MapReduce programming model. So in the MapReduce in the Hadoop, because all the operations to be expressed as MapReduce job, it was very essential to execute any type of task. We need to convert it to the MapReduce job. And writing efficient MapReduce program, especially in Java, is very complex for beginner. So that was also a main disadvantages of Hadoop. And non-MR use case. What is non-MR use case? Third section. Common operations like filter and join must be converted into the MapReduce logic. So if you are performing different operations such as aggregation, filters, and join on the data or shuffle the data, so the data means the operation has to be converted into the MapReduce logic. So that was very much important, and it was difficult for the beginners, and simple tasks require significant programming efforts. And most of the time, as we know, that Hadoop was supporting the Java, so it was complex as well. And we're talking about the programming APIs. Hadoop primarily supports Java. Means for the some features for the Hadoop streaming, it is provide different type of languages, but it was primarily supporting Java. So making it very much difficult for the user to be proficient in Python, R, and Scala. So there are different popular languages, and for those languages, scope was very less as compared to Java. Knowledge of JVM tuning and garbage collection is again required for the optimization. As we can read this topic, these are what is Java, JVM, and garbage collection. So all those topics, the beginner level as well as for the expert level, knowledge of these concepts was highly important for the Hadoop. And talking about how Spark is overcoming the Hadoop's limitation. Okay, so pay much attention here. So in processing memory, what we can say. So Spark load the data into the RAM, that is our primary memory, and reducing the I/O input output overload. It can be reduced by loading the data into the RAM. This is the first the disadvantage that we are, or limitation that we are overcoming with the help of Apache Spark. Okay, so unified data processing. So Spark not only processes the data in the batch processing, but it also processes the data in real time. And with the help of machine learning, it does not slow down the system. It is much more convenient with the machine learning algorithms to run the data in the back system of the servers as well. Okay, so this is also a primary advantage. Then user-friendly API, as we discussed just earlier, that only Java was supported primarily by the Hadoop and not the other languages. So the knowledge of the basic Java system or the basic Java language was highly uh, essential or prerequisite for the Hadoop. We can say that for the Spark, it is much more having the user-friendly API. Offers easy to use libraries such as PySpark and Apache Spark SQL. That is, you don't know, you know about the Python, Spark, and SQL, so that we can have the different kind of user-friendly APIs. Then optimize execution, as there is a concept called as a direct cycling graph, which we will see in this unit, and there is a very much efficient for task scheduling, and we will see that the topic later as well. Okay, so what are the theoretical concepts that we are going to see in this chapter? First of all, we will discuss about the resilient distributed data set. Okay, we commonly call it as RDD. Then the second topic is directed cycle graphs, so that is DAG, DAG. Then we will see about the Spark context, and then we will see about the Spark data frame, and finally we will see the actions and transformations. Okay, so talking about RDD, what is resilient distributed dataset? We can say that it is a type of fault tolerant collection. By the definition, we can say that it is a fault tolerance collection of data elements or data structure distributed across a cluster. So cluster means different type of nodes which we are going to use for data storage and processing. So what is basically RDD? RDD is a resilient distributed data set that are distributed collection of immutable Java virtual machines object that will perform the calculation very quickly. Again, we are discussing the topic in very detail. Pay attention here. What is RDD? RDD is a distributed collection of immutable Java virtual machine objects. These are the objects or data structure which you are going to see. So what are these objects and what is their operation? So we can say that it performs calculation very quickly, and these are the backbones of Apache Spark. RDD is a very much important point here. Okay, and if you don't know what is the meaning of immutable, so have you heard about the mutants from the MCU? Okay, what are mutants? Similar type of example, string class, or what are the mutants from the example we can say from the Marvel. We can say that Deadpool and Wolverine are mutants. Mutants means they can change their DNA. Their DNA was changed, so that they were the mutants. And mutants mean changes that can happen. And what are the immutables? So the keywords from mutants, from mutation are immutable, and we can say that from immutable, that is we cannot change them back later. Okay, so we can say that what are the mutables? Immutable. Once they are created, we cannot change it. Okay, once I'm repeating the same topic. What are the resilient distributed data set? So these are the distributed collection of immutable Java virtual machine objects. So that can perform calculations very quickly, and these are the backbones of Apache Spark. Okay, so that is RDD, and RDD are purpose built for distributed computing. So we can store the data as well as process the data on the multiple nodes. Okay, so RDD are purpose built for distributed computing, where they are a partition dataset logically, and this logical division that we are seeing paves the data for efficient and scalable processing by distributed different parts of data across various nodes within the cluster. Okay, so within the cluster we can say that we can process the data from the multiple nodes. So in that way, we can say that it is having the distributed property and lazy evaluation. So the RDD can also be generated from the range of data sources, including the HDFS or a local file system, that can also be created from the existing RDD through the transformation operation. Okay, what is the transformation operation? We can say that what are the transformation operation? We can create new RDDs from the existing one. We can create new resilient distributed data set from the existing one with the help of operation such as transformation. Okay, so they have different type of properties such as in-memory computation. As we discussed previously, in-memory computations involve processing the data stored in the computer's RAM, that is main memory, which is significantly faster from reading the data from the disk and results in faster data processing. Okay, so second type of feature we can say that lazy evaluation. Okay, so we did not discuss it. What is lazy evaluation? Lazy evaluation delays the execution operation until the result is explicitly needed, which will optimize the performance and resource utilization in the data processing. What are the lazy delays? It will halt or it will delay the execution of operation until the result is actually explicitly needed. Okay, so we can say that computations are delayed until action is called. So that is called as lazy evaluation, and we can say that it is the concept of Spark. So it has very high fault tolerance. How the RDD have a high fault tolerance? So fault tolerance ensures the system can be continued to operate without the disruption in the presence of hardware or software failures, enhancing the system reliability with the help of RDD. Okay, so we have discussed the immutability, that is refers to the data structures that cannot be changed after the creation, enhancing the data consistency. So if the data is not consistent, then we can say that the data is corrupted, the data is not available, or there is data is missing. So in the data integrity and data consistency are very highly important. Okay, and it will enable us for the parallel processing. So talking about the parallel processing, I can give you a simple example that you can relate. In Java, we can say that only multi-threading is allowed on the arrays only, not on the vectors. Again, I'm repeating the same. We can say that in Java, concept about multi-threading. Okay, so multi-threading is allowed only on the array data structure, not on the vector. Why? In the vector, data is elastic. We can say that vector is a elastic data set, sorry, data structure, so that we can add or as well as remove the data set according to our will, and the data set will be scalable. But whereas we can say that array, there is size is almost fixed. If we say that the 50 number of elements are there, okay, then we will only insert or add the element up to the 50. We cannot add it more. So it is possible to refer the data set for the multi-threading, so that the data is not corrupted and the consistency of data is there. Okay, then we can say that the next operation or next property will be the partitioning. How RDD will partition the data? So partitioning involves splitting the data set into the smaller as well as manageable portions that will allow the parallel processing and efficient data distribution in the distributed systems. So that is called as data partition. Also, there is one more property called as persistence. What is persistence? Persistence in a computation refers that ability to store the data or intermediate result to the disk or the memory for later uses, that will optimize the performance and reliability. Okay, so these are the various features of RDD, not only the property. So these are the various features, and as we say, there are operations on the RDD such as transformation. We can map the data, we can filter and flat map. These are the operations that we can perform under transformation. And what are the actions? So we can say that under there are two operations of RDD. So transformation basically involves processing applied to an RDD producer to another RDD. Okay, so we can have applied RDD to produce another RDD. We can say that from the parent RDD we can derive the child RDD using which type of function. So there are different type of functions such as filter, union, map, and more. So also there is a lazy evaluation is employed in their execution in the transformation operation. Okay, talking about the second operation about RDD. So what are the actions? Action return results to return the results to the driver program or write them to the storage. Okay, this will initiate the computation. So there are different type of operations such as count, first, collect, and reduce. So it can perform on the different data set. Again, talking about the RDD more, RDD are schemaless, meaning they lack a defined data structure for the data. So RDD is basically collection of different type of JVM objects. So there is no defined data structure provided. Hence, RDD are not type safe, which we can say that, which means that the compiler does not know, or the compiler knows about the columns of their data types only. So it is not type safe. So they can hold any type of data to be structured, semi-structured, unstructured. So the RDD can hold any type of data, that we can say that structured data, semi-structured data, or unstructured data. So they offer no compile time type checking, and data is typically processed using functional operations such as map reduce. Okay, so IDD are highly versatile, but makes less efficient for certain operations, as they do not benefit from the Spark's built-in optimization structure for the structured data set. Okay, so RDD are highly versatile, but these are maybe less efficient for certain operation, which are the operation, as they do not benefit in Spark's built-in optimization for the structured data. So we can say that there is a weakness for optimizing the structured data. It is not much beneficial in Spark. So talking about DAG here, we will discuss the DAG. What is the concept of DAG? So basically, DAG is concept of directed acyclic graph, which is utmost importance in the context of Spark. It is very much important, forming the bedrock. You know, bedrock. Bedrock means the highly important, means the foundation of the execution model. In this context, the graph pertains means sustains that two ways of tasks are organized while directed, and acyclic describes how these tasks are structured. Okay, again, once again, we are repeating the topic. The concept of DAG is very much important in the context of Spark, forming the foundation for their execution model. In this context of a DAG, we can say that graph are representing how the tasks are organized. Okay, graph will represent how the tasks are organized, whereas the directed and acyclic refers to how these tasks are structured. Okay, the term directed reflects the order of execution of tasks, in which order the tasks are executing, whereas acyclic signifies the absence of loops or cyclic dependency, how many times it will iterate. Okay, so that is represented by acyclic. So this architecture ensures that The each data processing stage depends upon successful completion of the prior one, because we are having the cyclic performation, and it allows individual tasks within the stage to operate independently. Okay, if there is any doubt, you can ask me. Okay, so we will continue. So we can say that in the essence of Spark, the DAG serves as a blueprint or foundation for the logical execution plan for the Spark jobs, and it will break down into the stages and tasks that can be executed concurrently across distributed clusters of machines. Okay, rather than the JVM that sorry, rather than the previous RDD, we saw that the DAG is very much helpful, as it is the key context of that in Spark. It has stages, task, and dependency. Okay, once again I'm repeating: stages, task, and dependencies are plays a very much important role in the execution of Apache Spark. Okay, so what are the stages? Stages are fundamental building blocks of a Spark job, which represent a task or set of tasks with a common set of transformation that can be executed parallelly. Okay, so in that, Spark divide the job into stages based upon the transformation that we can apply. Okay, so these transformation are categorized into two types. There are two types of transformation. Okay, namely narrow transformation and wide transformation. So narrow transformation can be computed within a single cluster partition on the RDD, and it does not require the data shuffling. And wide transformation involves the data shuffling, and it requires the movement of data between the partitions. Okay, so talking about the data transformation, there are two operations: narrow transformation and wide transformation. Talking about the narrow transformation, there is no need of data shuffling. Okay, while in the wide data transformation, there is need of data shuffling, and it requires the movement of data between the partitions. Partitions mean dividing the data into different partitions. So this is the influence of how the stages are formed. What are the stages? The Spark's job. The Spark job can be divided into different type of stages. Okay, so these stages are essential for optimizing the execution of Spark job. Narrow transformations within the stage can be pipelined together for efficient processing, whereas wide transformation introduce a barrier between stages for data structure, whereas the data shuffling is required in the wide transformation. So this allows the optimization like the pipelining of narrow transformation and minimize the data shuffling. Okay. So first step, we divided the Spark job into different type of stages. Then there are tasks. What are the tasks? Tasks are the smallest unit work in Spark, and these are really useful for the actual computation that we need to perform on the data. So each stage is composed of multiple tasks, and these tasks are responsible for executing the data transformation defined in the stage of specific partitions of the data. Okay. So Spark task scheduler is there, which distributed these tasks that we have divided across available workers nodes in the cluster. Okay, so there are some worker nodes, and each worker node processes a portion of data in the parallel processing, resulting in faster execution. So we can say that there is a factory and there are different type of workers, and we are assigning the task to each worker, and these workers are working parallelly in the industry or the factory, so that the execution is much more faster. Okay, rather than the we say that RDD, the data is processed step by step. We are having processing in this tag panel. Okay, with the help of workers. So we will discuss the workers in next session or later. So what are the dependencies? Again, in the process of tag, there are stages, there are tasks, and there are dependencies. So what are the type of dependencies? So dependency in Spark tag represents a relationship between the stages and indicates how the data is going to flow from one stage to another. Okay, so there are two type of dependencies, such like we can see transformations. There is a narrow dependency and wide dependency. So what are the type of narrow dependency? We can say that in narrow dependency, each partition of the child means the previous one, the child depends upon the specific partitions of the parent stage. What is narrow dependency? We can say that each partition of the child stage depends upon the specific partitions of the child stage that is called as narrow dependency. So this means that there are one-to-one mapping in the partition in narrow dependency, and again, no data shuffling is required. Narrow dependencies are common in data stages and data transformation. Okay, talking about the wide dependencies, in the wide dependencies, the partitions of the child stage depend upon multiple partitions, not only the single one or the specific partition. We can say that it depends upon the parent stage, and the data shuffling is again required as it is having the wide dependency. And this data shuffling can be resource intensive, and it can introduce the performance overhead in the wide dependency. So, in the contrast, we can say that each state comparisons of a set of different tasks aligned with partitions of the RDD, and it facilitates the parallel execution of the simple computation in the RDD. Okay. While talking about the DAG, user gain the ability to get into the each stage and delve into the deeper into specific detail. In stage overview, we can say that there is expand and explore of a particular type of all the RDD corrected in the particular stage. Again, the scheduler here divides the Spark RDD into discrete stages based upon the transformation that we can say that are applied. So again, there is also high tolerance in DAG. What is a high tolerance? A high fault tolerance. Okay. So that ensures that the robustness and the reliability of data processing using the concept of lineage. What is lineage? Lineage is basically concept of new RDD deriving a new RDD from the existing one or the parent. It is called as lineage. Okay. So DAG ensures the robustness and reliability of data processing through the concept of lineage. And basically, lineage is a record of a sequence of transformation that were applied to the generated RDD. Okay. So there are sequence of transformation that are available or applied to the RDD. As transformation are executed on the RDD, Sparks constructs the DAG. Okay, the RDD is the first step. Then the Spark constructs the DAG and simultaneously builds the lineage. What is lineage? The data that is derived from the previous RDD. Okay, so the new RDD is created, and the transformation that were used to delve in the each RDD. So this lineage transformation is crucial for recovering the lost data in cases of failure. Okay, so if there is partition in the RDD that is lost due to node failure or physical damage, the Spark can trace back the lineage to determine the original data source and compute the lost partition. Okay, with the help of we can say Spark, we can have the data in the RDD that is from the lost node, so we can trace it back to the lineage and determine the original source of data. So what are the previous RDD? What is the parent RDD? We can trace it back. So apart from the lineage, RDD can be made persistent with the help of operations such as cache or persist. So Spark stores each partition into the data memory on the disk and depend upon the chosen storage level. So this means that even if a node fails, Spark can rebuild the lost partition from the persisted data rather than recomputing the entire RDD. Okay. Finally, checkpoints is a mechanism that is used to periodically save the data. As if you have played different type of games such as IGI or different games, so there the if the player is dying, okay, if there is a difficult situation and you can say that the player is almost in the worst of the death situation, near to death situation, then we almost save the data. And if the player is getting successfully into the action, then we can resume the data. Okay, so there is such kind of a mechanism in the coding as well, where we can call it as checkpoint. What is checkpoint? We are storing the state of the data. We are storing the state of the data at some point, so that if in the other actions or next actions, if the data is gonna fail, then we can restore the data from the checkpoints. Okay, so finally this checkpoint added to the saved RDD to the stable storage such as HDFS, and this approach reduces the amount of recomputation required in the event of failures. So okay, so we can say that consider a situation that you are going to perform a bank transaction, okay, and hackers are attacking on the server continuously. And if the attackers are attacking, let's say the attackers are attacking through the use of DOS operation, okay, DDoS, you can say that, denial of service, and the constantly the data, sorry, the server is not available, then we are going to restart the server. Okay, the attack is over now, and we are restarting the server, and we are restarting the server. Then the data which was continuously giving. Okay, so data which you are currently having is lost because the server which are having the backup of the data and the remaining time from the backup from the current operation is lost because the data is not concurrently saved that much. So we can say that checkpoints are that much important in case of failure. So the RDD can reconstruct the data from the last checkpoint and from their lineage. Okay, and data processing optimization is also improvised with the help of DAG. How can improvise the data performance? So optimizing big data processing using DAG in Apache Spark is achieved through some techniques, through the use of pipelining, task fusion, shuffling arm optimization. We can say that there is a data locality, and another one called like, so task concurrency. Okay, so these are the type of operation that we can perform with the help of DAG. Again, if you want the overall description of this topic, you can ask me. Okay, so what is the first step, or what is the workflow of the Apache Spark now? Okay, understand the workflow. First, there is RDD. In that RDD, we can say that RDD is a JVM objects that are used to process, or we can say that are used to process the data. Okay, so this data is provided to the DAG scheduler. So the data set is then shuffled or split into stages of task, and we will give this DAG scheduler to the task scheduler. What is task scheduler? That it will launch the cluster manager. Cluster is for the data processing. Task scheduler will have that means it will go to the task scheduler and retry the task if it is failed, and giving the data back to the task scheduler so that it can send to the task scheduler. And in the final stage there is a worker, and worker is actually doing the task here. So it is almost executing the task and storing the data. So that is the overall operation. So we can say that the input is coded into the Spark console, and creation, we can say that including the creation of RDD and the applications of operation Spark constructor operator graph. Okay, so when the user initializes the action such as correct, the graph is sent to the DAG from the RDD. From the RDD objects, the graph is sent to the DAG scheduler, and the DAG scheduler decides the operation into the different type of stages and distribution them into the mapping and reducing operation that are performed by the DAG scheduler. Okay, so I guess so previous okay. So we will discuss the gas scheduler more. So each state in the third step, that is a task scheduler. Each state compromise of task based upon the partition of input data. The task scheduler optimizes the graph by grouping the operator together. And let's say for instance, numerous map operator can be combined into single stage. Okay, so this optimizes significantly to the contribution of Spark performance. The output of the task scheduler is set of well-organized stages, and in the final stage, we can say that these stages are handed over to the task scheduler, which are launches by the cluster manager. Okay, so before the cluster manager, the Spark standalone, Yarn, or Mesos, these are the task scheduler operators without knowledge of the dependency between the stages. So it will directly process the data. The actual action takes place in the worker node, whereas a Java virtual machine is initiated per job, as discussed in the RDD, and each worker node is solely processed code, just like the example that we discussed in the factory. So there are different type of worker, and each task is assigned to the each worker, and they are parallelly providing the data. So these workers are JVM workers, that is Java virtual machine workers per job. Okay, so we can say that Apache Spark has revolutionized the big data in terms of efficiency as well as flexibility, and it is very much fascinating to trace the data back to its history and evaluating them to the from the limitation of Apache Hadoop to become the open source giant as today. And we can say that that is very much important inside the Apache Spark. So we can we can study these topics into depth as well. But if you want to continue, we can continue with the other topics as tag and other. We can see the topic called as resilient dataset and tag in the detail. Okay, so we are reading the file from the RDD, then filtering the data. We are having different type of mapping transformation and reducing the results, and these results are given to the task scheduler for the tag. Then We are talking about the next topic, okay, called as data frames, that is Spark's data frames. So, what is a data frame? A data frame is a Spark is a raw data organized into rows and columns. Okay, so this is a conceptual similar to the CSV file or the SQL table, the CSV file which we saw in the machine learning. Okay, what are the data frames? So, data frames is basically collection of raw data such as CSV. Okay, so there are total number of rows and columns. This is called of which means the concept is same to the CSV or SQL table. So using Python and other Spark APIs, the user can interact with the data frame using common Spark command such as filtering, aggregation, and more for generally manipulating the data. The data contained inside the data frame are physically located across multiple nodes inside the Spark cluster. It is not only having the index format in the primary memory, the data is stored for the in the context of multiple clusters for the different location. Okay, so in the Hadoop cluster, the data is stored in the multiple nodes. The raw data is stored in the physically in the multiple nodes, and moreover, by representing them in the data frame, they appear to be a cohesive single unit of data without expressing the complexity of underlying operation. So that the physically which data is stored where. So that is not the problem. It is for the display purpose. It is represented as a cohesive unit or single unit to the user. Okay. So there is a point that data frames are not same as data sets. Another common term used in the Spark data set refer to the actual data that is held inside the Spark cluster, whereas data frames is a tabular representation of data set. Okay, so that is the difference between dataset and data frames. The dataset and data frames are API that are merged, and the dataset is now very much essential for the representation of rows. Okay, so that is the topic of data frames. As we can see, there is example from PySpark SQL import Spark session. Okay, so Spark session is very much important rather than Spark context. So Spark context is equal to Spark context dot builder dot app name. We have given app name as my app. Get or create. If there is already created, then we will get, or if that is not created, then we will create the Spark session. Okay. So DF means that it is a data frame, and df dot read dot csv, the data is extracted. The file name is data.csv. Again, header is true. We are displaying the attributes, and the info schema is true. For the rows and columns, we are having schema, and we are finally displaying the data with the help of the df show command. Okay, so that is data frame. As we discussed in the action and transformation, what is transformation? These are the operations that we need to perform on the data. So we are creating a new RDD from the existing RDD. Okay, for providing the data to tag, we are having different type of features such as map and filter. Map filter will apply function to each element, and filter will filter out based upon the conditions. Then we are having the actions. What are the actions? There are different type of actions such as a result to save or input. If you want to discuss these topics into the depth, then transformation specify generally the data manipulation operations such as filtering the data, joining the data, performing the aggregation, sampling data, and so on. So transformation do not return any results when the line is containing the transformation operation is executed. Instead, the command upon the execution, the supplement Spark uses DAG to correspond the request. Okay, so these are the operations that we need to perform: map, filter, or group by union. So these are the top type of operation. And talking about the actions, so on the other hand, action returns the results. Okay, so these are they executed into the series of transformation as the user have different type of specifying corresponding RDD that produces the output. Okay, so if you are not getting this point theoretically, or you need to visualize the data. Actually, I have not added the diagram here as the notes from the unit fifth. Okay, so this is the reference book. I hope you can see my screen. Okay, is my screen visible? Okay, I hope so. My screen is visible. So this is the book that we need to refer. Okay, so In the context, the data or we can say that the concepts are given very lightly, or the context is very little, except the overcoming limitation. As we can see, these are with the highly important topics such as RDD and DAG. Okay, so RDD context is given here very small, in the very small context, as well as DAG is given in the very small context, and there is no diagram here. Okay, again, this is the referred book from the syllabus. This is the same book called as Practical Data Analytics from the Nachaj Dasgupta. This is the same group. Okay, so these are the transformation, these are the actions, and if you are not able to understand these concepts, then I could share you one article. Okay, let me share my entire screen. Okay, I hope so. My screen is visible. So this is the article that you can refer. What are the concepts here? So in the Hadoop, we can say that. Okay, so there is big data. We are having different type of map operation along with the videos. So to get output data, again these diagrams are not recommended because these are not from the reference book. These are only to understand the concept. And if you are having talking about the RDD, then we are creating the RDD and having the lineage create new RDD with the given transformation operation, and then we are getting the results from the action. Okay, so transformation does not return any type of result, action does. So that is the difference. Again, resident data set. I highly recommend you to read this article. I will provide this article in the chat box. Okay, so this is the history of Spark. Then what are the concept of that? We are having the parallelization as well as data is provided to the next stage. So these are the stages. So you can read the stages from here as well. Stages, task, dependencies, then there are wide dependencies, there are narrow dependencies, then how the fault tolerance is given through the help of DAG and data processing optimization using DAG. Then what is the workflow? We can see that from the article itself that this is the RDD object state. Okay, from the RDD we are providing to the DAG scheduler, we are providing the data and splits into graphs such as stages or tasks. Then these tasks are given to the task scheduler, and in the background the actually worker is doing the work by executing the task. Okay, so this is the Apache Spark workflow. From the diagram we can see that. Okay, so if you want, I can give you this article in the chat box. Okay, so I hope so. This session was highly useful to you, and explore the concept by your own as well. I have mentioned the article link in the chat box, and if you have any doubt, they can you can ask me, or if you do not have any doubt, then you can give your attendance in the chat box. Okay, mention your division as well. So that's all for the session. Thank you for listening to me.